Hey, I'm back. Alright, sorry about that break. Let's hop straight into it. So subarray sum equals k. Turn the total number of subarrays. Ten to the 4. Alright, I think I understand. Let's test this theory. So 3, 1. The difference between the prefix nk has been seen. Let's see. One. Do this for example. 1, 2, 3, 4, 5, 6. And pretend k is 4. 3. 4, 3, 7. So 1. So the prefix sum array would be 1, 3, 5, 9, 12, 18. So 1 minus 7 is negative 6, not seen. 3 minus 7 is negative 4, not seen. 5 minus 7 is negative 2, not seen. 7 minus 7 is... 9 minus 7 is 2, which is not seen. But this subarray 4, 5, 6, 7, it equals 7. Okay. 12 minus 7, 7. 5, seen. 18 minus 7, 11, not seen. It's 1. Really 2. Oh, because this isn't, this is 3, this is 6. Which means this is 10, 13, 19. 6 minus 7, negative 1. 10 minus 7, 13. 13 minus 7, 16. Okay. I have a question. Alright. Turn to equals 0. 8. Oh, graph occur equals empty for enumerate turns into 1, 3, 6, minus 3 is 0. Oh, so you have to start with 0. cur 0 equals 1. Okay. For I num in enumerate nums. Cur sum equals 0. Cur sum plus equals num. Okay. Now pref occur for cur sum equals pref cur dot get cur sum 0 plus 1. Okay. If cur sum minus k cur top plus equals pref cur sum turn to cur sum plus equals num. F cur sum. If cur sum minus you need to go after. Toad. If there we go. What is this? Subarray sum equals k. TikTok. We'll do 8 slash, oops. Okay. Now what? Let's do subarray sums divisible by k. Subarray sums divisible. Subarray sums Sums k, return the number of non-empty summaries. I have a sum divisible by k. Oh, it's the same thing, right? Occur. Now we'll do like for example, let's use that example 4, 5, 0, -2, -3, 1, and k equals 5. So if we did the prefix, we get 4, 9, 9. This is 7, 4, 5. So as we iterate through, here's 5, 0. Oh, if it's 5. Wait, 9 mod 5 is 4. 9 mod 5 is 4, which is in. 9 mod 5 is 4, which is in. So which is in. Good. 4. It's 4. So 5, which is 2. 4. Is that the answer? What? What does sums do? Sums to 4. There could be a leading 0. So sums to 4. Sums to 9. Sums to 9. Sums to 7. Which sums to 4. Which sums to 5. So k equals 5. Leading 0. Okay, 4 corresponds. So this is what it's mod. 4 mod 5 is 4, 9 mod 5 is 4, 9 mod 5 is 4, 7 mod 5 is 2, and 4 mod 5 is 4. Okay, so 4 corresponds. Plus 1. Okay. Okay, well, curve sum equals 0, curve sum plus equals 9. Oh, path of cur 0 1. Sum if path of cur sum. Mod k. Oh my gosh, here we go. Why am I double typing the C? Occur. Okay, this should work. Okay. looks like we are going to move on to priority queues. Meeting rooms 2. Meeting rooms. What? It's locked? Does LeetCode have it? Meeting rooms 2. Given an array of meeting time intervals consisting of start and end times, find the minimum number of rooms required to schedule all meetings without any conflicts. Find the minimum number of rooms required to schedule all meetings without any conflicts. Send to the min heap of nlog n nlog n nlog n nlog n. We want to find the minimum number of meetings. Useful to think each meeting needs a room from its start time to its end time. Meeting starts after or at the same time another meeting ends. You can share the same room. Stores and end times of meetings. Sort all meetings by their start time. Initialize an ending min heap. start.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve meeting rooms 2, and just like the maximum number given in that first example, it's going to be difficult to one meetings, right? These are the exact kind of how we can visualize that. So this is kind of how we can visualize those meetings, right? These are the exact same meetings that we were given in that first example. We have one meeting going from 0 to 30, another meeting going from 5 to 10, and another meeting going from 15 to 20. Now if we just go from left to right, we're going to see, okay, well this is the first meeting that starts, right? It starts at time 0. And if we just keep going, now we see what's the next point on our grid, right? Well, there's another meeting, and this is not an end time. This is not, the first meeting isn't ending. There just happens to be another meeting that's starting. So another meeting just started at time 5. So what does that tell us? That tells us 2 meetings have started so far, but nothing has ended, right? There's no meeting that's ended yet. So at this point in time, we're going to have 2 meetings going on at the same amount of time. So what we're going to be maintaining is a variable count, which tells us at any given point in time, what is the number of meetings going on. And right now our count is 2, and we're going to end up returning whatever the max value this happened to be. So what's the next point on our grid? We visited this one, we visited this one. Now we're looking at this one, right? Okay, at time 10, there's an end point. This is not a starting value. This is a starting value. This is an ending value. So what does that tell us? That tells us a meeting has just ended. So what are we going to do with our count? We knew we had 2 meetings going on at the same time over here, but now after this point, we're only going to have 1 meeting going on, right? Like look at the picture. There's only 1 meeting going on, and it's this first one, right? 0 to 30. So we're going to set the number of meetings going on to 1. Now we're going to look at the next point in order. Now it happens to be a start time. So another meeting just started at time 15, right? So once again, there are two meetings going on, right? At this point, there's two meetings going on, the first one and this second one. So once again, a meeting started, that's going to tell us to increment our count. So now we're going to say two meetings are once again going on. And again, we're going to repeat the same process. The next point is at 20. This happens to be an end time. So that means a meeting is ending, right? We don't technically even know, is it this meeting that's ending or is it this meeting that's ending? It doesn't really matter to us. All we know is that after this point, only one meeting is going to be going on at any particular time, and it's going to be this one. So we're going to take our count of meetings going on, decrement it, and now it's going to be 1. And last but not least, we're going to go to the last point in our grid, and it's also a end time. Obviously, the last point is always going to be a end time for a meeting, so that means another meeting is stopping. After that point, there's only going to be 0 meetings going on, so therefore we can take our count, decrement it all the way down to 0. Now we notice that what was the max value that count happened to be? Well, the max it ever reached was 2, so therefore we're going to return 2 as our result. 2 meeting rooms is enough to contain all of these meetings. So let me show you quickly how we're actually going to be sorting these points and how we're going to be able to iterate through each point in order, regardless of if it's a start time for a meeting or if it's an end time for a meeting. So I'm going to slightly change the example in this case. So just by looking at the picture, what do you think the meeting rooms number would be for this problem? Well, you see over here, there's going to be 1 meeting going on. Here, there's going to be 2 meetings. Here, there's going to be 2 meetings. Here, there's going to be 1 meeting. But look at this point at point time equals 10. Clearly, there's 3 meetings going on at this time, or at least 3 meetings have a 10 value included in their time interval. Does that mean that there's going to be 3 meetings going on? Well, technically, the way this problem is defined, this meeting would end before this meeting started. What I'm saying is these 2 meetings are non-overlapping. So when we are going through this point, if we ever have a tie, meaning if we ever have 2 points with the exact same value, what we're going to do is we're always going to iterate through the end meeting time before we iterate through the start meeting time, right? Notice how this is a end time, this is a start time. We're always going to pick this one if we ever get a tie like this. So we're actually going to have 2 input arrays. We're not just going to sort every meeting based on the start time. What I'm going to do is I'm going to put all start times in a separate array. So 0, 5, and 10 are all going to go in a separate array. These are all the start times for any meeting, right? This way, we have them in sorted order, and we know, okay, these are the ones that are start times. We can differentiate between a start time and an end time. We're also going to put every end time in an array as well in sorted order. So we can see the first is 10, next 15, next 30. So now we're going to start this problem off with 2 pointers. We're going to have 1 pointer at the beginning of start and 1 pointer at the beginning of end. We're always, between these 2, we're always going to pick the minimum value. So we are going to maintain a count, which tells us the number of meetings that are going on. And if the minimum between these 2 is the start time, what we're going to do is we're going to increment the count of meetings going on and then shift our start pointer to the next one. And we can see that that's the case again, right? 5 is less than 10, therefore a meeting has to start before this meeting ends. So once again, we're going to shift our pointer over here and we're going to increment our count by 1. So the count is now going to be set to 2. And now we get to the edge case, right? We got a tie. So a meeting is ending and a meeting is starting. Remember, we are going to visit the end time if there's a tie first. So what we're going to say now is that, okay, a meeting has to end before this meeting starts. So we're going to shift our end pointer to the next one. If we iterate through an end value, that means a meeting just ended. Therefore, we're going to decrement our count by 1. So 2 is decremented by 1. It's going to be set to 1 now. Now, again, we're going to compare these 2 values, 10 and 15. Which one is smaller? The 10, right? So therefore, another meeting is starting. So we're going to increment our count by 1. So count is now going to be equal to 2. And now we don't even have any start times left. So technically at this point, we're just going to be iterating through the end time. So we're literally just going to be decrementing this. So we iterate through this, decrement this down to 1, iterate smaller, the 10, right? So therefore, we're going to decrement our count. That, okay, a meeting has to end before this meeting starts. So we're going to shift our end pointer to the next one. If we iterate through an end value, that means a meeting just ended. Therefore, we're going to decrement our count by 1. So 2 is decremented by 1. It's going to be set to 1 now. Now, again, we're going to compare these 2 values, 10 and 15. Which one is smaller? The 10, right? So therefore, another meeting is starting. So we're going to increment our count by 1. So count is now going to be equal to 2. And now we don't even have any start times left. So technically at this point, we're just going to be iterating through the end time. So we're literally just going to be decrementing this. So we iterate through this, decrement this down to 1, iterate through this, decrement this down to 0. So technically, once we've gotten through all start times, we don't even have to iterate through the remaining portion of end times. So what we can say is that our max count at any given point it reached was 2. So therefore, we're going to return 2. So that is basically the algorithm we're going to use, and coding it up isn't going to be too difficult. Yes, we are going to have to create 2 separate arrays, start and end, and we're going to have to sort these input arrays. So the time complexity is going to be n log n. The memory complexity is going to be big O of n. That being said, let's jump into the code now on LeetCode. So like I said, we are going to create an array for all start times in sorted order. Now, I'm sure you know how to do that in your language of choice, but in Python, there's a pretty easy way to do it. So we're going to go through for every interval in the list of intervals that we're given. Now, an interval is an object as defined up above. It has 2 member variables, start and end. So since this array is start, we're going to put every start time of this interval in this input array. And don't forget, we are going to sort it. And I can do that on the same line, just like this. We're going to have a similar array for end times, basically doing the exact same thing. So a sorted input array of i.end for every interval in the list of intervals. Now we are going to have a result variable and a count variable. So count is just going to be what I basically said it was going to be. Result is just going to continuously be whatever the max we have reached so far for the count variable. And we are also going to have 2 pointers. I'm just going to name them S and E. They're initially going to be both 0. So S is going to be the position we're at in our start array. E
List n times what is the top. Alright, so if pq and robots dot less than and pq keep up pq. Okay, let me try and code it up myself. So priority queue for actually let's sort the intervals. Intervals dot sort key equals lambda x, where x is compute 0. Then meeting start interval start after 0. Oh wait. Starts at 10. If the start time, what if the start time is equal? Will that change it? If the start time is greater than or equal to the end time. Starts at 7, end of 5. Medium. Reading rooms 2. Meeting. What are we at? Almost an hour. Let's keep going. Task scheduler. Kind of annoying how this one isn't on LeetCode. Task scheduler. Given an array of CPU tasks, each level of A to Z and a number n. Each label with a letter A to Z. The number n. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order. If there's a constraint, there has to be a gap of at least n intervals between two tasks with the same layout and a minimum number of CPU intervals required to complete. could do a heap where like for example, let me think, we have so to give us like for example is 2, so A, so we do A. Okay, we have a hash map where it has the count, so it's like A, 3, B, 3, 3, like this. And then we have and then we have like a total count, like total equals 0. So like A, B, or could we do A, B, 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 A. Is here. Should just do A, B. A. Or you still like 2A. Sorry, A0, 0A, 0B. Then you can do like 0A. Okay. Wow. So like wow, there's the length of our hash map. Okay, you did A, and then you got plus K, so it's turned into 2. Now you do, I don't know. What do you do? One way to approach this is to count the frequency of each side, then I can sort the frequencies in descending order to put it to. all tasks from the frequency map. For letter reference, letter count, and big items. I don't think you have to do it is that push PQ. Yeah, so what is going on? For count in freak. PQ dot keep. Oh wait, no. PQ dot keep push. PQ count. So that hires at the front while PQ will cool down. If PQ PQ task equals PQ dot, I'm sorry, heap Q dot heap pop PQ. I think that's the thing that is negative, not unnegative. PQ dot heap push negative task -1 interval plus equals 1 if elif or cooldown if cooldown and the thing at the front of the cooldown equal to So I'm marking this as the same as this one. Or I can do Coco eating bananas. I think I've done it. Coco. Yeah, look at me. Let me. Nobody's talking about the TikTok OA. But apparently they're hard. Should I give one more try? Grid traversals. Why you must be the shortest path in binary matrix. Shortest path in binary matrix. Like the shortest clear path in the matrix. There is no clear path. In binary, a clear path in a binary is the path from the top left cell to the bottom right cell. All the visited cells are 0. And all the adjacent cells. All the adjacent cells. All the adjacent cells of the path are. Grid 0, 0 equals 1 or grid then is number of islands BFS or GFS. is less than 0. If new I is less than 0, or new j is less than 0, or new I is greater than n, or new j is greater than n, or new or grid new I new j not equal to 0. Continue. Otherwise, otherwise, grid new I new j equals -1 ue upon new I new j a d plus 1. Yeah, this is, what are they doing? I'm gonna give that shortest path in binary matrix. I'm also giving it a yellow. Matrix. What's my count looking like? 180? 185. I like that. We got a contest going on right now. What's going on in this one? It's even moderation. Count of unfinished tasks after each of you are given 2 integer arrays tasks and should have tasks that I represent the target. Is it priority queue? What is this? How long have we been streaming? 143? I think we can do another. One more, maybe. Shortest path in a grid with obstacles. Elimination. Shortest path in a grid with obstacles elimination. shortest path in a grid with hard. Geez Louise. You're given an m by n integer matrix grid where each cell is either empty or an obstacle. You can up, down, left, or right from and to an empty cell. This is just like the same thing, but you store k in if the obstacle and k is greater. Okay, let me copy it. Where's my old one? Shortest path in binary matrix. Let's just grab all this. Alright. Oh, but this isn't naturally. Oh my goodness. So it's like this, but like.
Welcome to September's LeetCode Challenge. This problem is called Shortest Path in a Grid with Obstacles Elimination. You are given an m times n integer matrix where each cell is either 0, empty, left corner to the right lowest corner, given that you can eliminate at most k obstacles. So whenever we see a 1, we will have to remove it, but we can only remove k number of times. So here, the shortest path is just going to be going either down to right or right down, removing this one obstacle on the way. So already we can kind of tell we want to use a breadth first search, and they tell you that right in the hints right here. But we want to use a breadth first search with one extra parameter, r, which is the remaining number of obstacles that you can remove. So that's going to be big. We have to keep track of how many obstacles we can have left. And that way, if we find that we have none left, then we're not going to continue our breadth first search. But one other thing that is going to be a little tricky here is we also need to keep track of what we've already visited, right? Normally you have some sort of visited set to keep track of the cells that you've already visited. But here, say that we travel down one path and run out of obstacles, you can easily imagine some other situation where we're going to come back to that same cell in order to find the shortest path in some other different path, right? But we've already visited that cell. But we haven't visited that cell with that many moves left. So what we're going to do is have some sort of visited set that not only keeps track of the XY coordinate, but also how many Ks do you have left. And that way, it doesn't matter, how we got there. It only matters that the first time we hit there, how many moves do we have left? And if we come back here and have more moves left, that would still be the shortest path, right? All right, so let's begin. Let's first initialize our m and n to be the length of grid and length of grid 0. Now we're going to have a queue, and in this queue, what do we want to have? Well, we want to have the xy coordinates, right? We also want to have how many k's we have remaining, so xy, as well as obstacles, I guess, as well as how many moves have we taken so far, because we still need to keep track of that, right? Yeah, so we'll have k here, and we'll have 0, which is the number of steps we've taken, so we'll call that steps. Right, so while we have a queue, let's first pop off. Here, how will I do this? I think xy is fine, as well as the number of obstacles we have left, how many do we have left, and we'll call it steps. So here we'll say pop left. So a couple conditions. First things first, if we find that x, y, and number of steps or number of obstacles left is in our visited set, so we'll call it seen. then we actually can't continue here, right? So we'll just continue. We also need to make sure that we have steps left, or not steps left, we have obstacle numbers left. So we can also say, let's see if it's in scene or left is less than 0. That means we should just continue here. Okay, we should also have our base case to say if, let's see, x, y is equal to m minus n, or m minus 1 and n minus 1, then we've hit the right corner. So we just return the number of steps right here. And finally, let's go all 4 directions. Oh, actually, first we should add to our set. So we'll call it scene add x, y, left. And we're going to say, let's call it dx, dy in, okay, well, we'll have the 4 directions that we can travel. Let's see, so 1 to 0, negative 1 to 0, 0, 1, oops, and 0 and negative 1. So as long as the new coordinates that we calculate, so we'll call it new x and new y, as long as this is inbounds, we're going to add to our breadth first search, right? So let's see, x plus dx and y plus dy. If new, let's do like this, 0 equals new x is less than m, and 0 greater than equal, new y is less than n, we're going to append to our queue. Let's see, the new x, the new y. Oh, I suppose we need to, if this coordinate is, if it's an obstacle, we need to subtract 1 from the number of obstacles we have left, right? So, okay, let's see, if, do I do it up here or what? Let me think. I guess we can just do it up here. If grid x, y is equal to 1, then we're going to subtract from left minus equal 1 like this. And that should be fine. Left and number of steps plus 1. All right, so if we're able to come out of this loop though, if we never return the number of steps, the first time that we hit our right bottom corner, that should be the shortest path. But if we can't get there, well, then we just return negative 1. All right, so let's see if this works. Okay, that looks like it's working, so let's go ahead and submit that. And great, so time complexity wise, oh gosh, what is the time complexity? Time complexity, since we have our scene set, I guess it's going to be n times m times k. And space complexity, same thing because of our set here. So yeah, I think it's n times m times k, and that's it. Now there are a couple variations to this, but this is the one that I found most understandable. Yeah, so hopefully this helps. And
Oh, you guys are, sometimes I forget I'm streaming, man. Anyway. What is going on here? See, but like... Does his code... What did we just watch? What happened to that, guys? Where's this code at? Is this the pro? Oh, here we go. So for his code, Q equals DQ. We've gone 0. What? Alright, we need to review. I need to review this. Alright, maybe I'll do that tomorrow. Alright, tomorrow's my I really hope I don't get one of these on the TikTok. But with my luck, I don't know. I mean, maybe I'll practice tomorrow morning or something and do it at like mid-afternoon. But I have some research papers to write. I don't know. We'll see. We will see, I guess. Interesting. Mid-meeting rooms. Yeah. Well, it's good to see that this one I got green. And this one. Progress. Any other progress? Oh, merge K. Progress. Income. Alright, well maybe I'll do the Wordle just to get us to 2 hours, and then I'll see you guys tomorrow. I'll try and stream in the morning because I don't want to waste too much time. This can't be that hard. Privy. How do you spell privy? Oh, there you go. Look at me. Alright, well, I guess with that, I'll see you guys tomorrow, and I've done Coco's. Should I just do Coco's Bananas really quick? Just to prove that I can do it? Because it says Coco's Bananas is a separator, but in my opinion, that's not really a separator. And banana, and piles of bananas. The ith pile has I bananas. The guys will come back in H hours. You can decide, Cook can decide her bananas. Each hour she chooses some bananas. Less in case she eats all of them. Alright, tote. Oh wait. Nine, 16, 20, 13, 16, 27, 8. Oh, okay. Biggest equals max of piles. If sounds like unlog in. Oh, login. Maybe this wasn't as easy as I thought, guys. Mid minus 1 plus 1. So what do I need to do? Division by 0. Oh, come on. Cocoa eating bananas. What is this? Medium? Dang it, I thought I could do better on that one. Cocoa eating bananas. But I have to give myself a yellow because I was disappointed. Alright. Well, we're definitely over 2 hours now. Well, I'll call it a night for now. And like I said, I'll try and stream before my OA tomorrow to get some practice in. But if I don't, then I'll obviously try and stream after, and I'll let you guys know how it went and how this practice helped. But regardless, I'll see you guys tomorrow.